funny enough, it's a bit more complicated for us, but not because because I know that some of you mentioned to me like you thought it would be more complicated, but it's actually we have been building all our service images on both architectures for quite a while, just because we want everyone to be able to like run the services also on their laptops, and so there wasn't really a problem with the building. But then, like, we want to make sure that actually the performance is what we expect from the services. So that's actually something we were not really confident, like, from the platform engineering team to roll out everywhere. So it's something like we enabled, but then we left it up to the teams. We said, like, okay, this is available for you. We would like you to adopt this, but you need to run some performance tests before you release it in production. And I think there's also like there's a tricky situation, like being a central team and pushing something in the organization. So I had a look earlier this morning, and I think we had like 60-70% adoption. So it's not that all services are now running on Graviton. We still have a few left.
Sam, I guess what was the inkling that like what was it about migrating from RDS? What was it about migrating RDS to Graviton versus ECS tasks? That makes you say like, oh, this ECS aspect is more difficult or more complicated?
Well, I mean, the ECS part, obviously. So as I said, with a product like RDS, it's a managed database. You're connecting to an endpoint. Under the hood, to get that working, Amazon would have had to do some work, and the different database engines that they're running would have had to be compiled for that architecture and so on. That's all obfuscated away from you. You don't have to worry about that. When you're building containers, as you would be for ECS or Kubernetes or anything else, and you change that processor architecture underneath, even to a lesser extent when you change from Intel to AMD, depending on how specific your code sets can be, then you need to recompile everything, and you need to make sure all the different libraries and all the different things that you're using support that architecture underneath. And the ARM ecosystem, if you will, has lagged behind the Intel because it hasn't been as popular in production systems for big companies. That's changing these days with not just Amazon, but I mean, Apple have been putting the ARM processors in their Macs for the last couple of years now, and there are a lot more people using them. So a lot of the libraries and utilities and programs that we use regularly in a containerized system have now been updated, and it's okay to go ahead and compile that. You still need to obviously do all your testing and everything else because there's a lot more riding on you to make sure you got that right.
Yeah, that's exactly what I expected, Sam, that when he told me that you thought it would be more difficult. But for us, since we went through the painful process already when people started getting laptops with the new chips, then we basically had to solve it before we even looked into getting to Graviton instances.
And then of course, you've got all the performance comparisons, as you mentioned, to make sure that it's at least as performant as you require, and in the end saving you some money, hopefully, which we're lucky it did.